Okay, hello everyone. My name is David Lara. I'm a fellow classmate of yours in the CIS 231 class. Um, this is my video demonstration for the code, the MASM code that I was able to put together to for this lab assignment, which is the Fizz game. So a Fizz game is traditionally played by as many players as you'd like. It's basically a counting game where in places of 3, 5, and 15, numbers that are divisible by those numbers are replaced by words instead of numbers. So fizz, buzz, and then fizz buzz. Fizz replaces 3, buzz replaces 5, and fizz buzz replaces 15. So this little graphic here will basically show you how the game is played as instructed by the professor. Um, Basically the prompt of the lab assignment is to write a MASM code that will print the typical round of fizz buzz game up to the number 46. So typically that game does not have an end, does not have a range, but we're given one here to help our keep our code simple, help keep it, concise. So then we're going to modify the code to ask the user to enter the range of numbers you want to start with and stop the game. So you're going to validate your entries and make sure both are positive integers and the second number is greater than the first. So that's basically what we're asked to do. And then I'm going to shift over here to kind of show my code. Um, So before I start getting into what the code is, let me actually run it really fast. So I'm gonna run it. Brief little thing too from my last video, I couldn't get my command prompt to work properly, but after a while it sort of came back together. So that's why I'm able to enter the debug and then just start the program this way. So I'm gonna go ahead and input a range of 1. We're gonna start with 1 and then we're gonna do 23. So as you see, it's outputting line by line. So I added a delay in here to be able to slow down the output because it was just spitting everything out. And I feel like this is better for the user so that, it'll be kind of like you're counting, slowing things down, making things easier to read, easier to understand. And it looks better, honestly, than just outputting the entire string of everything. So 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz, 16, 17, fizz, 19, buzz, fizz, 22, 23. So that's a correct assessment of how the game is played. So that works properly. I'm going to go ahead and run it one more time and just kind of show an error that I was not able to fix, and I didn't really understand how to, so I'll get to that right now. So I'm going to input a decimal digit of 0.5, and then I'm going to do 40, 30, 25. Okay, no, my bad. It was 1.5 and 25. So no matter what I put, it's going to take it as a whole number. It's going to not round it up accurately, but kind of round it to the first integer in the decimal. So the first whole number that it sees, and it's going to take that as the input. That was an error I was not able to fix in this code. Having to create the range and stuff, I just couldn't find a way to validate it. I hope that in the future I could figure it out, but for the time being, that was the only error I came across when running this code. And I'm just going to kind of show you too that it does not take negative numbers. So 22. Okay, I'm going to show that it does not take 0. Okay, it does not take 0, and it's outputting an error message to the user to let them know where they went wrong. And then we're going to go ahead and showcase that it does not take a number less than the start. So if I start with 5, it's not going to take 4 as an end. See, there we go. So it's outputting everything correctly. The only issue that I personally ran into was just the fact of outputting a decimal, well, using anything other than a whole number, pretty much. That it's just picking it up as a whole number. So let me go ahead and close this and let me jump straight into the code. So breaking everything down here, everything that was asked for is in here, plus the addition of something else that I had to find online in order how to implement, figure out how to use it. And that is just the add for the delay so that the output would output line by line as opposed to just spitting everything out. So let me just start at the top here, and when I get there, I'll kind of show you what I'm talking about. So include Irvine 32. This is for the library call so that we can use all of the instructions and all of the functions that we have in Irvine 32. This is required in every code that we use here in MASM just to be able to have access to those libraries and those functions and those instructions. Um, So that is nothing new. That's in every one of our code. I separated everything data code, but I added spacing in between each function and each specific instruction just to showcase everything more easier and just for it to be easier for me to understand. Let me just erase this line. Sorry about that. Let me just build it. Okay, so that's kind of my logic behind why I did that in that way. That's why there's a lot of spacing here. I'm sure this code could have been a lot shorter if I would have squeezed everything in together. So that being said, this is my data set. So all of these are my string calls. So basically they're going to be, they're in forms of string bytes that we're going to go ahead and call. Hold on 1 second. Okay. Sorry about that. Okay. So these are all messages in the code that we're storing as byte strings. So these are all prompts and messages to the user that will be outputted to them so that they can be easier to find it. And these are the abbreviated formats that we're using in our code in order to implement things. So the zero in every line is a null terminator that is required for every string byte that we're calling in our data. And these will be printed using the right string. So if we continue down here to the code, everything is pretty much chronological. So this is required no matter what, the main proc. But this is our first function. So we're going to get the input from the user first. So we're going to ask for the start number, which will be offset into the EDX format. Um, so we're going to print the prompt. We're going to print prompt to the user using the right string down here command. Then we're going to get input with the read int. And this result will start in EAX, but we want to move it in EBX. So that's kind of why I wrote right here that it's going to be EBX equals start, because that's where our start number is going to be. Similar format down here. So we want this to be an ECX. We want the end to be an ECX. Since there cannot be equal values, they have to be in different memory locations. Since they're unique addresses. They're unique numbers. They cannot be the same memory location. So we want one in EBX, one in ECX, and they always start at EAX. So that's just kind of the logic of how the memory locations work. So next we start working into the validation for the input range. So somewhere in here is where I went wrong regarding the decimals, and regarding the fractions and stuff. But for the most part, everything keeps it to 1.1 and 46 range. So we have our jump instructions right here to be able to jump and show an error in case it does not fall into these categories. So everything's pretty much protected in that regard with our compares here for EBX and ECX regarding the integers given. Since these are the ranges, then we will show the error if, for example, this specific one, if the end number is greater than 46, we're going to show an error, and so forth. So this is basically to catch any input errors in our code regarding that specific range. And what's nice about this too is it automatically takes into consideration the sign of the number. So we only want positive numbers. We don't want zero. We want everything to fall into this specific web. And it does so. It catches everything except for the decimal and the fraction. So right here, we're going to go ahead and initialize the loop. So we're going to keep looping while ESI is less than or equal to the end number. When ESI is greater than end, then we're done. So that's kind of how everything is going to be happening internally to monitor that we reach the end and it doesn't go on forever. So next, what we start with is our different loops. And we're going to go ahead and check for divisibility regarding the integers inputted by the user. So if the number given is divisible by 15, then we're going to go ahead and print FizzBuzz. If the number given by the user is divisible by 3, we'll print Fizz. If it's divisible by 5, we'll print Buzz, and so forth. So if the number is not divisible by any of those, then we're going to go ahead and continue the loop. Before I jump into these, basically what we're doing here what we're doing here with these strings and printing, is we're calling these functions down here. So these functions are written to continue the loop until we reach that endpoint that I spoke of earlier. So these are the functions that they're calling in there. We're basically writing the string of the print buzz, we're calling it, and we're showing it to the user. We're outputting it to the user. So kind of how these divisibilities are going to work in the code are we're going to put our number in EAX from ESI, right? We're going to clear the EDX because we need it before the divisibility happens. Then we're going to divide by that number that we want, so 15, 3, or 5. If the remainder in EDX is 0, then it's divisible by that number. And that will tell us what to output, the function will know what to call, and that's why we have the jumps here. So we know what to jump and we know to compare it if the remainder is 0. So if the remainder in EDX is comparable to 0, then we know to jump to the function of print fizz, print buzz, and print fizz buzz, and so forth. So now that I'm having more familiarity with the jump instructions and the compare instructions, it's easier to understand how simple this is using those. Because without it, it would have been a headache. But that's kind of the logic as to why these are here. When we scroll down to our continue loop, this function is something that I had to research online, regarding how to slow down the output to the user, which is kind of what I spoke about earlier in the video. So I was able to find a delay function that we're able to call to be able to move everything at a slower pace and kind of output line by line. So that's what this is. So this value of 500 is moved into EAX. And then we call the delay function, and then this is going to slow the output to the user. So this doesn't really do anything negative to the code that we have here, but that's why we're incrementing the ESI to not deter away from what we have going on with the ESI up here. So we do not want to mess with this because this is going to continue the loop and it's going to tell the program when to start, when to stop. And if the ESI counter gets off the fritz, then it's not going to know when to stop, not going to know when to begin, and it's going to continue. So if the number is not divisible, then we're printing the number and then moving on. So the code knows to always keep moving until we reach the end program, which is down here. I added another show error in here, so this will actually show the error message as shown up here. In the off chance that something had happened regarding the code towards the end of it, after the loop counter had already ended. But I never really needed it. I just kind of left it in there in terms of probability for debugging, just in case I found any issues or anything. Um, so yeah, that's the artificial delay I added in here, and then that's basically an explanation of all the code and why I put that in there. So the code works just fine. It was just that one error that I had, and in order to kind of explain my thought process, I saw EBX, ECX, and ESI as easier ways to store the start, end, and current numbers. Like I said, unique memory locations and so forth. Um, and then using the labels that I kind of shown to you here, so print buzz, continue loop, and so forth. Then being called jump to the program to be able to add a delay into it and so forth. These labels were definitely easier to follow in terms of when I was debugging. And I'm sure as a new user, looking at it, will go ahead and kind of show that um, it's more step by step and logical as opposed to just a giant mess. And then something I wish I would have gone over, but I didn't actually here. So the CRLF command, let me see, present in every one of these calculations prints a new line after each output. So this does essentially the line by line showcased in the output to be able to show the string of numbers. So 1, 2, 3, 1, 2 fizz, and so forth. Um, this makes it appear on the output as opposed to just ignoring it and just displaying one line of the answer and so forth. So without this specific instruction, the entire code, the entire output would have been um, redundant and not appropriate to the assignment. So a lot of these um, A lot of these instructions and a lot of these coding decisions I made were actually a big thanks to the demonstrations shown in class. But yeah, for the most part, that is my decision and why I implemented everything the way I did, and this is what my code looks like. So I'm just gonna go ahead and build it. Well, I built it already. I'm just gonna run it one more time. And then let me just show 7, 13. So 7, 8, fizz, buzz, 11, fizz, 13. So this outputted line by line, it looks nice. It's a little slower, but it gets the job done. And I prefer it this way. So yeah, if you have any questions, let me know. Thank you for watching, and have a good rest of your day.